warahmatullahi wabarakatuh, and a very good day to everyone. We are from Aida Sdn Berhad Company, going to present and share about our interesting finding and solution, which for our main topic, which is the cost-effective solution in utilizing electrical energy system. So, based on the topic, we have our own goal in this project. The goals are to investigate suitable solution for housing development. The reason why we are doing this is to encourage sustainable energy use to support the developmental growth of the nation according to the 11 Malaysia Plan. Not only that, we also propose engineering innovation to encounter the problem and issue in this topic. The methods on how we solve the problem are by doing site visit, which to find the best place for housing development, do the observation on the existing system, make a comparison to find the best outcome, and we also do a redesign to reach our goals.
Assalamualaikum and hello. My name is Muhammad Afiq bin Ahad Isam. My metric number is AE190052 and now I'll be in charge on site summary. So this is our site. So the name of the site is number 6 Jalan Melewa 1 Taman Melewa Parit Raja, Johor. So the details of the site location are 1. Longitude 103.1008662. The latitude is 1.852191. And lastly, the altitude is 8.721347. So shown here are the photo of the site visit that has been done. So from our site visit, we observed and calculated the assumed electrical bill per month. It is extremely high for this type of building, which is single-story terrace house. So this is because the existing electrical appliance, it consumes a lot of electricity above the average. So this is why and the main reason we choose this building.
My name is Amar Safi Arifin, matrix number AE190061, and I'll be presenting for analysis and discussions. So for analysis, we have two parts, which is load consumption analysis before and load consumption analysis after the improvement. So for the load consumption analysis for before, as you can see in the table here, we have 7 electrical appliances, which consists of fluorescent lamp, ceiling fan, 2 types of ceiling fan, which is 3 blades and also 5 blades, switch socket outlet, 13 ampere, washing machine, refrigerator, and stand fan 60 inches. So for the total maximum demand, when we calculate, we get 3,308.8 watt. While for the maximum demand, the total maximum demand we times with coincident factor, which is 0.9, to get the answer, which is 2,977.02 watt. Moving on to the after load consumption analysis for after improvement. In the table, we can see there are a few improvement we made for our electrical appliances, which is the fluorescent lamp we changed into LED lamp. Ceiling fan we changed from 5 blades to 3 blades, and also the table fan we changed from 16 inches to 12 inches. From that, we calculate the total maximum demand to get the answer 3,173.40 watt, while the maximum demand, we times the total maximum demand with coincident factor to get 2,856.06 watt. As you can see, there are slightly changes and also decreases in value for total maximum demand and maximum demand after we make an improvement for the electrical appliances. And after that, we will move on to another part of analysis by our group members.
Assalamualaikum warahmatullahi wabarakatuh. Dr. bin Hamid with topic number 80 So next, we will continue about the analysis and discussion part. So next, we will see about the solar designs. So we will see about how to design the solar panel suitable for the housing. So first, we will look for the PV panels. So we choose the monocrystalline PV panel with the rating 400 watts. So we are considering to use two PV panel for the house which are enough for the common house. So the PV power it will um, produce about 800 watts daily. So it is enough for the house. Next is for the battery bank. So for the battery bank capacity utilization, we use this formula to calculate the battery bank. So the daily consumption is for the daily house usage, which 2,856.06 watts. So use this for the calculation and we get 87.50 ampere hour. So the suitable battery bank capacity is 100 ampere hour. And lastly, we will see about the inverter. So for the inverter, it is impossible for the usage of 100%. So we are considering about 70% until 80% efficiency of the inverter. So the power needed for the inverter is about 3,570.08 watts. If we considering about the safety factor, we will need to times the power calculate previously with the safe factor which 1.25. So it is to protect the inverter from the voltage spike and power surge. So we will from the location we will get 4,462.6 watts. So the suitable power rated for the inverter is 5,000 watts. So this is all for the solar designs. Next, we will discuss about the electric tariff estimation. So the table show the domestic tariff produced by the TNB. So we can see the tariff is different, have a different current rated. So we will see about the tariff before and after the design. So we can see the difference between the electric consumption. So as before, we have 2,143.5 kilowatt hour with the tariff 1,105.64 ringgit. But after the design, we got 1,480 and 0.36 kilowatt hour. And as for the tariff, we got 726.99 ringgit. So the cost reduction, which are the difference, is about RM 378.65 ringgit, so, which are about 34.25%. So as for the common user, it is pretty low uh, for the before and after the design. So we can say here that it will reduce quite a lot of money for the user. So that's all for the analysis and conclusion.
Next, moving on to floor plan layout and single line diagram. So for the single line diagram, you can see from the picture here, connected source with cutout neutral link 30 ampere and is connected with kilowatt hour meter. And after that, it will going through MCB 40 ampere, which act as a circuit breaker, and then it divided to two types of resistor bin, which for the first one is 40 ampere 100 milliampere, while for the second one is 40 ampere 30 milliampere. So for the first one, it is connected to several electrical appliance, which is it is connected with 6 ampere fuse, while for the RCCB 40 ampere 30 milliampere, it is connected to output, which consists of heavy duty appliances and also switch socket outlet that is with connected and controlled with 20 ampere fuse. So that's all for circular diagram, and move on to floor plan layout. I will pass to our group member.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Next, I would like to present about the design floor plan for this project. So I use the AutoCAD software. So as shown in the screen, this is the before plan that I designed. before the improvement in order to get the energy saving. So as shown in the screen, let's see in the dining room and the living room, there are 1, 2, 3. There are 3 usage output that used in the living room, which is 2 fluorescent lamp and 1 5-blade ceiling fan. So next we go to the first room. There are 1, 2, 3, also 3 usage output, which is the table fan, 1 fluorescent lamp, and 1 3-blade ceiling fan. Also same for the room 2. So we go to the toilet for the room 2, which is using the fluorescent lamp. And next we go for the dining room and kitchen. There are 5. There are 5 device output that use, which is 2 fluorescent lamp, 1 5-blade ceiling fan, 1 washing machine, and 1 refrigerator. So we go to the next room, which is the third room, which they consume for also 3 device output, which is 1 fluorescent lamp, 5-blade ceiling fan, and table fan. And also the toilet, we're using the fluorescent lamp. And we go for the outside of the house, which is the garage place, using the 2 fluorescent lamp. So we go for the after the improvement. So if we can see here at the outside of the house, which is the garage place, we improved that. The before that we use is the fluorescent lamp, but here we use the LED, which is 2 feet, which is consume less energy. So we go for the living room. We use the LED lamp with 4 feet, and we switch from 5-blade ceiling fan into 3-blade ceiling fan. So it's saving more energy by that. So we go for the next room. Also, not really have change for the room 1 and room 2, but for the room 3, we change the 5-blade ceiling fan into 3-blade ceiling fan. And also for the kitchen, change the fan. And also all in the house, we use the LED lamp 4 feet in order to get the saving energy. So that's all for the design planning for level plan house. Thank you.
Finally, to conclude our finding, we were able to propose the new design of electrical system for the housing development. Not only that, we were able to investigate suitable site location for the housing development. Both are the outcome that help us to reach our goal to determine cost-effective solution in utilizing electrical energy system. Thank you for your time and have a good day.